Good morning, student. Today we'll discuss about the carbons compound. It's a very important chapter. We'll expect 15 marks from this chapter. Carbon and its compounds. Its compounds. Carbon and its compounds. First, carbon atomic number is 6. Electronic configuration. Electronic configuration. 1s2, 2s2, 2p2. So, carbon will have in K shell 2 electrons and L shell 4 electrons. To become an octet, we need 8 electrons. To become an octet, 8 electrons. If it is 2 electrons, it's called as a duplet. 2 electrons. So we can see the duplet example, hydrogen. Hydrogen is electronic number 1. So like that, hydrogen H2 bond. So hydrogen will have a 1 electron and another hydrogen will have the another electron. So this is duplet. So this is the example of covalent bond. So covalent bond nothing but it's a mutual sharing of electron. Mutual sharing of electron. Mutual sharing of electron. So let me discuss about in case of carbon compounds generally have generally they are generally they all are covalent compounds. So covalent compounds. Let us see properties of covalent compounds. First one, they have low melting point and low boiling point. Low melting point and low boiling point. And second property is they are poor conductors of electricity. Let us see one example of hydrogen. Hydrogen between there is only one single bond, that is called single covalent bond. Single covalent bond. Let us see double covalent bond. Double covalent bond. Double covalent bond. Let us take another example, oxygen molecule. So oxygen atomic number is 6. Electronic configuration 2, 6. 2, 6. So oxygen electronic configuration, let us see the electronic configuration. 1s2, 2s2, 2p4. It means there is a 6 electrons in the outermost shell. How many electrons? 6 electrons. Here also same. 1s2, 2s2, 2p4. So outermost shell consisting of 6 electrons. So here it is required to become octet configuration. It's need 2 electrons. It's need 2 electrons to become octet. So let us see here 1, 2, 3, 4. Okay. Here also 1, 2, 3, 4, 5, 6. So another axis also 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So here this is the type of examples. Okay. So mainly we have to focus on triple covalent bond. So triple covalent bond, let us see an example, nitrogen molecule. Nitrogen molecule. So let us take nitrogen. Its electronic configuration 2, 5. Nitrogen atomic number is 7, 2, 5. So here we'll get, let us see nitrogen. Here also one more nitrogen molecule, 2 molecules we said now. So 2, 5. So nitrogen, another nitrogen. So K shell consisting of 2 electrons. And here also 2 electrons. Are remaining 5 electrons. 1, 2, 3. Here also 1, 2, 3. So to become octet, it required 3 electrons to become. So this is we already said like that. Covalent compounds are mutual sharing of electron. It's called mutual sharing. So here also this is called mutual sharing. This is called mutual sharing of electron. So covalent compounds are nothing but they have the mutual sharing of electron. Mutual sharing of electron. Mutual sharing of electron. Why are we talking about mutual sharing of electron? Nothing but carbon compound. Let us see the carbon. Carbon is atomic number 6 and electronic configuration is a 2, 4. 2, 4. So its outermost shell consisting of 4 electrons. Outermost shell consisting of 4 electrons. So let's see 4 electrons. Outermost shell consisting of 4 electrons. 4 electrons gaining and 4 electrons are losing, these two conditions are, it's a very feasible. It's a very feasible. Very feasible. So this is the topic whatever we discussing about the covalent compounds. So we can expect 1 or 2 questions from this topic. 1 mark, 2 mark question we'll expect from this in this topic. Okay. Thank you. This is the concept of sp3 hybridization, sp2. Let us see sp3 hybridization and sp2. It is also same one s orbital, 2 p orbital overlapping each other, we call as sp2. So here sp2. So example sp2 we can take as a sp2 hybridization and sp hybridization. Here sp2, these are the very important. sp2 and sp2 means 1 s orbital and 2 p orbitals. 1 s orbital and 2 p orbitals overlapping each other. So we know that s orbital is the shape is spherical shape. Spherical shape. And 2 p orbitals, maybe p orbital is it's a dumbbell shape. We know that this is the s orbital. S orbital and p orbital has a dumbbell shape. This is the dumbbell shape. P orbital. This is already studied in structure of atoms, 6th chapter. So p orbital, and here it's a, so if you take the direction, it's a px, it's a py, it's a pj. Because if you take an axis, we'll get it. So 1 s orbital, 2 p orbital overlapping each other, we get sp2. Here s orbital, sp orbital, it is also sp orbital, 1 s orbital and 1 p orbital. You get the overlapping each other, we can say that it is called as sp hybridization. What do we call? sp hybridization. Then I look at example beryllium chloride. Beryllium chloride, BCl2, beryllium chloride. So here in this case, beryllium is a central atom. Here beryllium is a central atom, chlorine is a surrounding atom. So beryllium is a central atom, chlorine is a surrounding atom. Let us see for example, let us see beryllium. It's chlorine and it also one more chlorine. So this is the bond angle between the 180 degrees. So 180 degrees. So sp hybridization is bond angle. Its bond angle is bond angle is, let us see. So let us see the bond angle. We'll write as a deep, okay, sp3. So bond angle sp3, bond angle is sp3, bond angle is 109 degrees 28 minutes. Then the bond angle is 109 degrees and the shape is tetrahedral. Tetrahedral. And sp2, its a bond angle is its a bond angle is 120 degrees. So bond angle is 120 degrees. 120 degrees bond angle, and the shape is trigonal planar. Trigonal planar. sp2. You can say that and sp, the final hybridization sp, the bond angle is is 180 degrees. The shape is linear shape. What is the shape, that one? linear shift. So these are the brief explanation about the hybridization, sp3, sp2, sp. sp3 hybridization is bond angle 100 degrees 28 minutes and shape is a tetrahedral, and sp2 is a bond angle 120 degrees and shape is a trigonal planar, and sp bond angle is 180 degrees and shape is a linear shape. This is the theme of the hybridization. Next, going to next important concept. We will not discuss much more. So these are the exam point of view we are discussing. Next, carbon mainly perform two very special characters. Very special characters. That is first one, tetravalency. What is that one? Tetravalency. And second one is a catenation property. I will explain about what is the tetravalency, what is the catenation. First one, tetravalency. Tetravalency is nothing but the carbon valence is 4. That's why we call as it's a tetravalency. If it is 1, we call as mono. If it is 2, we call as divalence. If it is 3, is a tri. 4 is a tetra. So carbon can perform. Carbon valence is 4. Definitely it's a tetravalence. That is a tetravalence. The next most important special character, that is catenation. So catenation nothing but carbon is a peculiar behavior. What is that? Peculiar behavior. It's a very important. 1 mark, 2 marks question will expect here. A peculiar behavior of the carbon can perform making a chain with its own atom. That is called catenation property. So next we move on next level in this chapter. Next, I'm saying very important concepts. What do you expect in this exam manner? So sometimes we'll ask the difference between the diamond and graphite. So diamond and graphite. We can say that diamond is a sp3 hybridization. We'll go undergo the sp3 hybridization. Graphite is a sp2 hybridization. Okay. And it is a very hardest substance. Diamond is a very hardest substance. Graphite is when compared to the diamond, it is not that much a very strengthy material. And we can from the graphite we'll abstract the graphene. It's a very valuable material. And graphite is a very good conductor. It is a very good conductor for electricity. And diamond is a very bad conductor for electricity. So that is a very important. So we know that sp3 is a tetrahedral and here the trigonal planar. Okay. Next one, the most important, nanotubes. Very important, nanotubes. This is very important. Nanotubes will get the 2 marks question. So nanotubes are firstly introduced by the Somio Lijima. 1991. So the nanotubes are widely used in the medicine field and IC circuits IC circuits. IC circuits, and one more. In a medicine field, it is a medicine IC circuits. In telecommunication field, IC circuit will use in telecommunication field, and in medicine purpose, medicine field used biomolecules. Biomolecules to make a inject single cell. But, in this carbon composition, most important, hybridization. What is hybridization? The intermixing of orbitals. Almost have the equal energy. Reshuffle. To make it reshuffle, almost have equal energy is called hybridization. Mainly hybridization mainly in this 10th class portion have the three types hybridization. That is first one, sp3 hybridization. This is very, very important. Hybridization, sp3 hybridization, and second one sp2, and third one is sp hybridization. sp3, sp2, sp hybridization. Let us see first one, sp3 hybridization. I'll say very simple. So hybridization, here we have one formula, generalized formula, how to calculate hybridization. Very, very important formula. This is, in this way we can find out easily hybridization. So half into number of valency electrons of central atom. Valence electron of the central atom plus negative charge minus positive charge plus number of monovalent atom. You can say that monovalent electron or monovalent atom. In this manner, we can easily find out which kind of hybridization, whether sp3 or sp2 or sp. Let us see. sp3 or sp. Let us take an example. For example, I need to calculate the CH4, generally we call as methane or else marsh gas. So methane or marsh gas, it's a methane. So it's called as methane. So methane, I need to calculate CH4 methane, which comes under which kind of hybridization, whether sp3 or sp2 or sp. By going in this formula, substitute, we can find out hybridization. So half number of valence electron of the central atom. So here central atom is carbon. So in this carbon, the carbon belongs to 4th A group. So definitely there is no much think about that. 4 valence electrons. 4 plus. Is there any negative charge? Nothing. Positive charge? No. So directly number of monovalent atoms. So here monovalent nothing but Monovalent nothing but only valency electron is one is called as monovalent electron. Let us see example: hydrogen, fluorine, chlorine. These are all monovalent. Iodine. So let's see. Half plus. How many monovalent atoms are there? 4. So Z is equal to half. 4 plus 4 is 8. Divide, get the 4. So 4 means it's a sp3 hybridization. 4 means sp3 hybridization, 3 means sp2, and 2 means sp hybridization. 4 means sp3, 3 means sp2, 2 means sp hybridization.